Good afternoon, respected dignitaries, distinguished scientists, esteemed guests, and dear colleagues. On behalf of the fraternity of the Sri Chitravinal Institute for Medical Sciences and Technology, I extend a warm and heartfelt welcome to each one of you. Today is a proud and historic occasion for all of us as we inaugurate the Center for Space Medicine and Research, the Center for Skill and Simulation Lab, and mark the beginning of post-doctoral fellowship course in bioastronautics. We are deeply honored to host luminaries from the Indian Space Research Organization. We shall begin the inaugural ceremony. May I now request Honorable Director, SCTMST, Dr. Sanjay Bihari, Head Biomedical Technology Wing, Dr. Harikrishna Verma, Deputy Director, SCTMS, Dr. S. Manikandan, Dr. Roy Joseph, Head of the Department of Material Science and Technology, former Dean, Honorable Director, Human Spaceflight Center, ISRO Bengaluru, Sri Dinesh Kumar Singh, Honorable Secretary, Department of Space, and Chairman ISRO, Dr. V. Narayan, to occupy the dais. We now invite our respected director, Dr. Sanjay Bihari, to deliver the welcome address.
Respected Dr. Nayan, the Secretary of Space, Department of Space, we're very, very honored to have you here. And along with you, we have Dr. K. Singh, the Director of Human Space Flight Mission, Dr. Unikrishnan Nair, who's the previous Director of Vikram Sarabhai Center, and all the other illustrious guests on the dais and off dais. And I'm also grateful to the other members of ISRO and also the member of the Trivandrum Science and Technology family for being here, and also the fraternity of Sri Chitra and everyone else who's here. Today is a day my dream has come true. It's almost like a surreal experience for me to be standing here and talking about a center for space medicine, which was only something which I had ever imagined. Certainly the energy of ISRO has actually pushed it through. And I think the people sitting on the dais are actually solely responsible for all the hard work. I just go through the steps. Actually, Dr. Narayanan, when he was the director of the liquid propulsion lab, he had just invited all of us in honor of Dr. Somnath, who was then the Secretary of Space. And at that time, we just happened to just mention the fact that the difference between Vikram Sarabhai Center and Sri Chitra only 6 kilometers away. We looked it up in the Google map and then decided, well, here is where we require a collaboration. But I had not expected it to go with the speed that it has gone through. And then the next thing which happened was suddenly Dr. Unikrishnan Nair took the proposal and sent it up to Dr. Somnath, and then Dr. Nayan, who are good luck, all became the secretary, and he immediately came to sign the MOU with all the other directors. And then we come to today when we are actually formally starting the Space Center. And on behalf of the entire Trivandrum family, the Sri Chitra family, I think we need to give all these eminent people a big round of applause for the energy. So, is this cooperation on space medicine that we envisage to carry out? So there is about 6 major areas that we actually think this can actually develop into. First is, of course, preparing for the human space flight mission. And we are so proud of the wonderful work which ISRO has done. because of which certainly all of us in science and technology and in STEM suddenly feel important in the country, that our actual work is being valued simply because of the wonderful work which ISRO has done over the years. And I think this is something that can be acknowledged. So first is preparing for human space flight mission, the key. The second important thing is remote remote therapeutic interventions and telemedicine. That is one area which really need to develop into, because I mean, it's not possible to take all the machines into space and any emergency can occur. So a remote intervention is something that we really need to look at, and remote communication is another area we need to look at. The third is developing technologies that are related to space missions and microgravity. A person goes up in space, there is a G force on the person, then how the person has to lie down, how the person has to sleep, what is happening to the circadian rhythm. This is another big aspect which needs to be looked at, and especially in microgravity, that's something we have not been able to emulate on Earth. This is something which we are just trying to actually experiment and do. The other important thing is conducting research in microgravity. And I have been informed by Chairman Sir and by all the illustrious ISRO faculty here that they would like all the youngsters and all the faculty members to actually suggest different projects which we can take to the International Space Station. And with those projects, they can actually vet out those projects, and then those one or three selected ones can actually be performed in space and taken it through. So this is another area that we need to work on. And then it comes, one important aspect, Sri Chitra's mandate is to make medical devices. And over the last 5 years, we have almost made 21 devices which have been translated and 5 have been commercialized. So I think one important aspect is cooperation in making devices, medical devices between Chitra and ISRO is a very important part of the mandate. And sixth is also very important that the offshoots of the devices which are used for space can also be used on Earth for everybody around us. So these are 6 important mandates of this important area. Another very important aspect which is being done today is starting a postdoctoral fellowship, which is post-DM, post-MCH or PhD fellowship on bioastronautics. So this was actually suggested by Dr. Unishan Nair some time ago. He had written an article in 2019 on bioastronautics, and I remembered from there. And what does it actually mean? It includes in space, physiology and health. Then human performance is a very important aspect of this aspect. Life support systems are needed. Emergency response systems are needed. That's the third point. Protection and safety for the people. Behavioral health is a very important aspect. You are isolated in space. You are surrounded with people whom you are not very comfortable with. Their cultures are different, their languages are different. How do you actually perform under stress? It's a very important aspect. And of course, the most important of this is technology development. And I think ISRO and Sri Chitra, and of course, also leapfrogging of the other organizations which are in Trivandrum. And because of the very vibrant science and technology of this city, I think this is the most appropriate place for the starting of this. And of course, CDAC is also a big contributor to it. So this can actually be fruition. The second important aspect that Sir has inaugurated today, which is the need of the country, is the Center for Skill and Simulation Lab. And this has come up with a generous grant by Dr. Mr. Alok and Shalini Verma. They were the, Dr. Alok was the brother of Dr. Anup Verma, who was the president of Alumni Association of Sri Chitra till very recently. And only about 6 months ago, suddenly he collapsed and passed away. And just before that, actually, he's a very eminent neurologist. He was from Manchester. He was a very senior consultant, and he suddenly passed away. So his family has given the generous grant, and we are still developing it. And this will become a skills and simulation center. What exactly is a skills and simulation center? Say, for example, if you're doing some surgery, then before you go in to do surgery, you can actually practice the surgery. You can see all the steps of surgery on your computer. You can actually do a simulation of every single aspect of whatever procedure you're planning to. That's something that you practice before you actually go on to human beings. That's the need of the hour now. The second important thing that you can do in simulation is that every medical colleges now have more and more students and less cadavers to actually do real-time work on. So with simulation, with developing of mannequins, with developing of software, you can actually do in a simulated atmosphere what you are actually doing in real time on cadavers. So this is a very important aspect, and there is no other institute in the country which is actually working on simulation. And I think it's time for all of us to also start focusing on simulation. I'm very honored and grateful to all of you for joining in at this historic moment. So I would like to just share with you a beautiful poetry which I just just read about. So with your permission, sir, can I just, it's a small, very small one. So it's my dream on the cusp of fruition. This is written by Maria Parent. So it says, dreams like rivers flow deftly in my mind, offering nothing with each twist and wind. But unlike the stream, life's course can be led. As wants become musts, as passions are fed. As time slips by, as the moments take leave, I'll reach for the stars, hope to believe that someday I will make the right turn, bring all that I am and all that I have learned. As my dreams unfold each step to the next, unravels the game, unfolds the complex, until I'm standing now toe to toe with all that I am and all that I know. On the cusp of fruition, my dream, of all that it seemed, of all that life is, and of all that I have dreamed. Thank you so much.
Thank you, sir. We now invite Dr. S. Manikandan, Deputy Director, SCMST, to present a brief introduction to the Post-doctoral Fellowship course in Bioastronautics.
Few, sir. 6 slides. So, respected Dr. V. Narayanan, Secretary ISRO, respected dignitaries on the dais and off the dais, we are planning to introduce a new course in the curriculum of Sri Tirunal Institute for Medical Science, which is considered to be a post-doctoral course in bioastronautics. It's a new domain. As you know, that there was a MOU signed between SCTM and ISRO on 25th of April 2025 for the inauguration of the Center for Space Medicine Research. And a follow-up, we have been continuously interacting with ISRO. We know that ISRO has gone leap and bounds. And then we are almost like our fourth in the world in terms of the space technology, but we are reached up to the thing in the space medicine. As you know, Prime Minister Sri Narendra Modi ji has told in the Independence Day, the vision of ISRO and humans should reach the space, and we have to build a space station International Space Station, what the US has done. So, and it's also has given a very vast book on the capacity building and public outreach. Is a very wonderful book which has been released by ISRO in May 2025, where they have highlighted various aspects of human space program which need to be undertaken. So the part we discussed over 3 or 4 months was how to go about the research. The basic understanding was we don't have a specialized manpower because we are all doctors, we are engineers, we are all doing multi-purpose jobs. But we have to have a specialized skilled manpower for carrying out the indigenous space medicine. The hospital wing, BM wing, and Human Space Flight Center of ISRO came together, and the idea of starting educational program, and we thought about starting a PDF course, which is a short-term course. So it could be an introductory course over which can build upon further in PhD or other MS program and these other programs. Why bioastronautics? Why not space medicine? Was a question. Bioastronautics is basically how the human being adapt and mitigate all the challenges of environment posed by microgravity to space. So it covers the area starting from space flight, development of various human flight and safety methods, life protective systems through which the human has to undertake when they travel through space. When I was looking through what the similarity between the space travel and every day-to-day being, I am the anesthesiologist. So every day we undertake the similar things. What a space mission ISRO is undertaking. Every patient who has come for surgery, they have to undergo stress testing. They have to, as the fitness, we have to improve their fitness and then take them through the anesthesia, provide a safe surgery. And after the surgery, we are bringing back to life and ICU care, post-rehabilitation care. A space mission almost akin to the similar, we have to screen the astronauts, ensure the safety methods, ensure the fitness, and then undertake space experiments in the safe way. After coming back, we have to have monitoring their health as well as rehabilitate them physically and mentally. So we have sufficient knowledge, we have sufficient expertise in Chitra, and we are very happy to collaborate on this program. The objective of the programs are to build space medical operations and to conduct and publish high quality research and to contribute to national space policy. Right now, we don't have any health policy related to space, and we are going to formulate various guidelines related to technology, material selection, as well as various normative data on the human when related to space. So the basic training research includes end-to-end mission exposure, which include understanding of human space flight cycle, including crew selection, pre-flight screening, in-flight operations, planning, and post-flight rehabilitation. Also, active research during these various programs also being encouraged, including ground-based analog simulation platforms, flight experiment, and various other opportunities will be given to candidates. We have developed key training modules with relate to space medicine. Some of the training modules will be undertaken at the HSFC of ISRO at Bangalore, and some of them will be done at SCTMST with related to medicine. We have envisioned 2 positions annually and the duration of 12 months, and various term and conditions admission process will be as per the SCTMST. So the unique features of the fellowships include structured dual institute training, and we have dedicated mentors who are specialized in certain areas. Every area we have dedicated mentors who are experts in their field. And also we have various advisory committee to go through all this rigorous screening, research and publication and patent and other things also will be included in this. So we have produced a diverse background. It could be from the medical stream like MD, MS, DM, MCH program. Also, we are include PhD from biomaterial sciences, life sciences, and engineering sciences. These people also qualify this PDF program. So the PDF in bioastronautics will be certified after evaluation. They will be having 6 monthly evaluation. So we have other PDF programs. The outcome of program envision is upon successful completion, be competent, contribute to humans, spaceflight medical operations, and to possess interdisciplinary expertise spanning clinical medicine, biomedical engineering, aerospace physiology, and various human factors. And they should be positioned for career advancement in space agencies. Now, majority of space is all again private partners are coming in the way. They should find a big opportunity in private place. So our outcomes of the institutes in HSFC, we build an in-house medical expertise because they have a lot of engineers, but they don't have technically medical expertise. We'll be contributing to the medical expertise for the human space program like Gaganyaan and other future spacements. And ACTMST will establish leadership in space medicine and biomedical engineering for space applications in India. Future plans, setting up and modifying existing various labs for the space mission. Inclusion of PhD curriculum also in space medicine in the existing PhD curriculum of CTMST. And also we encourage startups related to space, various devices and development in technologies at our Chitra campus. Thank you so much.
Thank you, sir. May I request Dr. Unnikrishnan Nair, Director, VSSC Trivandrum, to say a few words to the gathering.
There's a correction. I am not Director VSSC. I was Director VSSC. Beloved Chairman Road, Directors Sri Chitra Institute, Director HSFC, other dignitaries, all those who have assembled specialists from medical field. So I used to say ISRO to space program. Similarly, the bio or the medical field, Chitra Institute of Medical Science is like a towering figure in the area of medical science. How is standing for space? But yesterday we had a 2 days meeting, but the visibility of Tirunal has to be improved for the services you do the nation. Now today it is a new chapter, that is Bioastronautics. Till now we have been speaking about Gaganyaan, that's going to space, 400 kilometers and come back. And the moment Narayan has assumed power, he's just given he's going to give more challenge. Take people to moon. Anyway, the work is going on. It's not at approved. But ISRO is making a work. ISRO is trying to get the approval. But it's a Herculean task, a role of astronauts and the type of medical support and the type of training we need to do, the simulations experience that we need to on ground is huge. So when I visited IBMB in Russia, that is one of the best biomedical institutes in the world, started somewhere in 60s. So let this be the beginning of a major step in our country for combined activities of all our areas related to bioastronautics, not only at Sritra, but all like-minded institutes can come together and act as a fulcrum for advancing the astronautics in the country. Because we need to know what humans are undergoing when they are subjected to space. And unlike an aircraft which is going through the space at a very comfortable speed, a rocket is traveling at 28,000 kilometers per hour, and in 8 to 10 minutes it reaches from atmosphere to space. So the mindset, what we call as the astronaut mindset, and the physiological power, what they need to take up such activities, huge. So I'm sure this golden beginning. A special congratulations to your director, and also our chairman has taken so much pain to come and inaugurate. It shows how much importance ISRO is attaching to such beginning. Thank you very much.
Thank you, sir. It is now my privilege to invite Shri Bish Kumar Singh, Honorable Director, Human Space Flight Center, ISRO, Bengaluru, to address the gathering.
Honorable Chairman ISRO, Dr. V. Narayanan, Dr. Sanjay, Director, Sri Chitra Institute, Dr. Unnikrishnan Nair, my predecessor, as well as for Director VSSC, and all the dignitaries of DIAS and DIAS. When we signed the MOU, I just made one statement that we don't want this MOU only to remain on paper. The same day, I also realized Dr. Sanjay is not the ordinary person. His enthusiasm and commitment shown on that itself, I knew that this is going to happen. So I'm really glad that you have not kept it on paper. You have sown the seed of bioastronautics in India, in true sense. And that is a great achievement for Sri Chitra too. And this will go in history, I tell you. Okay, now ISRO means, I will just say 5 problems. So when we are in human space flight program, so integrate human into the inning system is the biggest challenge. And I have more questions than answers, and I need experts to work on those questions and give us the answer. One of the problem is when we do any engineering system, we were following NASA mill standards. Is consciously looked at it and evolved our own standards. Now I give a challenge to Sri Chitra that can we evolve our standard for human spaceflight for the human systems. If that comes, that will be a great achievement for the country. So all this, thank you.
Thank you, sir. May I request our Director, Dr. Sanjay Bihari, to present an intro to Shri D.K. Singh. I invite Shri D.K. Singh, Director HSFC, to accept the token of appreciation. Thank you, sir. Ladies and gentlemen, we now come to the most awaited session of the afternoon, the honored guest lecture on theme Indian Space Research Organization, the Milestones and the Future. To introduce our esteemed chief guest, may I invite Dr. Roy Joseph, Head of the Department of Technology and Quality Management and former Dean.
It's okay. There's one video in the same folder. Okay, it will play, no? No. Huh? I have to see separately. Right. Okay, that is. That's it. Go to the folder recording. Order. You can click here. This has to be played first. Not now. After. Close it. Okay, sir. 1 second. The resolution is much. 1 second, sir. സാറ് ഇൻട്രോഡ്യൂസ് പറഞ്ഞു ഞാൻ പോരാ.
Respected Chairman, Space Commission, Chairman ISRO, Honorable Secretary of Department of Space, Dr. Narayanan, Dr. Dinesh Kumar Singh, Director, Human Space Flights under ISRO, Dr. Sanjeev Hari, Director, SAT-MSc, Dr. Unnikrishnan Nair, former Director, VSSC, Dr. Verma, Head BMD Wing, Dr. Manikandan, Deputy Director, and my dear delegates, distinguished personalities, VSSC, and my dear friends. It is truly an honor and a privilege for me to introduce an extraordinary visionary, a pioneering scientist, and an inspiring leader, Dr. V. Narayanan, Chairman of the Indian Space Research Organization, to all of you. Most of us know him well through newspapers and TV. He was our guest of honor during our annual convocation 2024. For the sake of those who do not know him personally, let me introduce him. As an Indian rocket propulsion expert and aerospace engineer, Dr. Narayanan's journey is a shining example of dedication, brilliance, and service to the nation. Dr. Narayanan was born in Melekat village in Nagarkovil in Kanyakumari district, Tamil Nadu, and completed his early schooling in his hometown. He earned the first rank in Diploma of Mechanical Engineering. Later, he received associate membership in Mechanical Engineering from the Institution of Engineers. He attended the Indian Institute of Technology, Kharagpur, to pursue a master's technology in Galvanic Engineering. He performed exceptionally well in his M.Tech degree, earning a silver medal and first rank upon graduation. To further demonstrate his proficiency in this area, Dr. Narayan took a PhD in aerospace engineering. He joined Indian Space Research Organization in 1984 and served in a number of positions. In January 2018, he was appointed Director of the Liquid Propulsion Systems Center. He helped create the solid propulsion systems for the Oriented Satellite Launch Vehicle SLV and Rohini sounding rockets early in his ISRO career. Dr. Narayan was the project director for the Geosynchronous Satellite Launch Vehicle Mark III, that is GSLV Mark III, C-25 cryogenic project. He oversaw the group that created the C-25 cryogenic stage, which uses liquid oxygen and liquid hydrogen to power a 20-ton crush engine. The GSLV Mark III vehicle was successfully launched on this stage for the first time. Dr. Narayan has been pivotal in several key Indian space missions. Under his guidance, LPSC developed propulsion systems for Chandrayaan-2 and Chandrayaan-3 missions, including L110 liquid stage and C-25 cryogenic stage for the EBM-3 propulsion systems. These systems were crucial in transporting this spacecraft from Earth to Moon's orbit. He also chaired the national level expert committee that analyzed the Chandrayaan-2 landing and recommended improvements contributing to the success of Chandrayaan-3. For the Gaganyaan program, India's human spaceflight mission, Dr. Narayan has been involved in human rating the LVM vehicle and developing human-rated L110 and C32 cryogenic stages, environmental control and safety systems, and propulsion systems for the service and crew modules. As chairman of the mission review of the test vehicle T mission, he oversaw the successful demonstration of crew space system. Dr. Narayan's contribution has been recognized in several awards: Gold Medal from Astronomical Society of India, AS Award for Local and Related Technologies, ISRO's Outstanding Achievement Award, Performance Excellence Award, Team Excellence Award, Honorary Doctorate of Science from Satyabhama University, Chennai, Distinguished Alumni Award 2018 from IIT Kharagpur, National Design Award 2019 by National Design and Research Forum Engineers India, National Aeronautical Prize 2019 by Aeronautical Society of India. Recently, that is in this year 2025, he was honored with 3 more awards. APJ Abdul Kalam Award by Government of Tamil Nadu on 15th August 2025. And during his 13th convocation ceremony, University of Burdwan conferred him DSc degree in honorary capacity. G.P. Birla Archaeological, Astronomical and Scientific Institute honored him with the G.P. Birla Memorial Award in July 2025. Dr. Narayana is a member of International Academy of Astronautics, of Indian National Academy of Engineering, member of Space Propulsion Committee of International Astronomical Federation, National President of Indian Society of Systems for Science and Engineering, Fellow of Institute of Engineers India, Fellow of Indian Cryogenic Council, Fellow of Astronomical Society of India, served as a member of INAE Governing Council and member of various national and international professional bodies. He is also serving as a member of Governing Council of Board of Indian Institute of Space Science and Technology and Academic Council member of many engineering colleges. The Department of Space appointed him as a chairman ISRO and he formally took charge on 14th January 2025. With nearly 3 decades of experience in rocket and spacecraft propulsion, Dr. Narayan's appointment as ISRO chairman marks a significant milestone. His expertise and leadership is expected to steer India's space program toward new achievements, further solidifying nation's position in the global space arena. I welcome him to this function once again. Now he will be giving lecture on the topic Indian Space Research Organization, the milestone and the future. Over to you, sir. Thank you.
Caller mic or the mic, you know? Okay, fine.
Answer. Share. Okay. Share. Oh, no. Screen. Oh. Okay.
Yeah, most respected and beloved, and one of the dynamic doctors, Dr. Sanjay Bihari, Director of Chitrathirunal Institute of Medical Research and Science. Dr. S. Manigandan, Dr. Raj Yusuf, Dr. Harikrishna Sharma, Head of VMT Wing, and my colleagues, the founder director of the Human Space Flight Program, and former director of Vikram Sarabhai Space Center, and currently the Vikram Sarabhai Professor of ISRO, Dr. Nikrishnan Nair, currently the director of Human Space Flight Center, and who is always under fire, Mr. D.K. Singh. I just told he has shared his responsibility to director. Because whatever question we ask there, what are you doing on this area? And half of the problem he has transferred to the director. And very, very distinguished friends, very, very good afternoon to all of you. Actually, I was wondering how your director is functioning. A great neurosurgeon, a fantastic director, and an outstanding human being, and a dynamic person who connects with a lot of people. And really, I don't know how God is giving 7 hours per day for him alone. This is the type of output what is coming from him. And this entire thing happened. In fact, he asked me to, number one, to come here for inaugurating these fantastic facilities. Really, it is my honor and privilege, and ISRO's honor and privilege that we are here for inaugurating the skill lab. Skill lab, I have heard in engineering, but I have seen in medical field. Of course, recently also I had the opportunity to see in Pune some of the things, but practically we are seeing what you are doing. It's a fantastic lab, what is inaugurated. Second thing is, when you talk about postdoctoral fellowship course on bioastronautics, I think it is the first time in the country. As my friend D.K. Singh told, it is going to be written in the golden letters of Indian science and technology that first time this activity was studied here. And then, of course, we also inaugurated the Space Medicine Lab. Now, when you look at Indian space program, there are a lot of milestones. I think I am not going to do all those things. But one of the important milestones is very easy to remember for us. 23rd August 2023 was a historical day, and India is the only country, first country successfully soft landed near South Pole of Moon and made every Indian proud, that you are all aware. And same way, 20th April 2025 is another historical day, very easy to remember. We signed a MOU with Sri Chitra for the space edition. So 20th August 2023, 25th 2025, 25th April. And you know, when we sign lot of MOUs with lot of people, but everywhere everything is not taken forward in the right spirit, right speed. But here is a super jet which is happening, and lot of things are done. Now there are a lot of people behind, solely your enthusiasm, interest, everything. Second thing is there are people like Nikrishnan Nair who have understood little bit more on this area, the engineering and medical. And he is also there. Probably it is his suggestion, bioastronautics. And the next one is D.K. Singh. He is one of the outstanding communication scientists of the country. And he is currently the Human Space Flight Center director. And there is a problem. A person who got 100 out of 100 in mathematics, all of them he is to ask to work on geography, and there he has to show 100 out of 100 score. And you know how difficult it is, and that is the he is there. Very smart guy. He has transferred 50% of the problem to your director. So now he will tell, sir, it is near your place, and you talk to him. And doesn't matter. That is the way only we have to work. It's not hard work which matters. It's the smart work what matter. Now, friends, coming to Sri Chitrathirunal Institute, I think probably we used to make one statement: the alien, when it moves, it doesn't know its power in. But we know what it is. Same way, lion in the positive sense. When a lion is going, it's know what it is. Simply it is walking. But we all know what it is in a positive sense. What is its energy? Same way, is your institute, outstanding institute. I was telling director, whenever we see your institute, we see like a temple only. Temple or church or mosque, whatever you call it, is the way we look at it. And the people with great dedication, commitment, the type of what you do, it's outstanding and outstanding work. Now, let me tell one or two things. 1947, we got independence. Average life of Indian hardly 32 years. Today, it is 72 years. And in the human life, when somebody is getting married, it is a fantastic day, getting married. To a woman becoming pregnant, the entire family celebrates. But there was a time the MMR rate was so bad. Even the villages used to think somebody is getting pregnant, only 50% chance to escape. And same way IMR, very bad. Today, we come to a greater levels. A lot of people who have contributed for those things. And that too, when you talk about a heart, I understand, I worked in the cryogenic program. We have developed a pump for putting hydrogen, liquid hydrogen. We have taken almost 12 years to develop a pump which has to work for just 20 minutes, which has to deliver constant pressure, constant flow rate. We have taken 20 minutes, 12 years we have taken. And God has developed a pump which grows continuously over 23 years, if I'm correct. And the capacity changes. Then it has to work continuously for 75 years to 80 years. And you are the people, when maintenance is required, you are the people who does the maintenance job. And we cannot think about a pump which can be made by human being continuously varying the capacity. We cannot make. I am sure God has made such a fantastic pump, and you are people who are doing changing heart, ball, change this, that, everything. And today I have seen this heart self, and fantastic work you are doing. Chandrayaan 3 we have succeeded, and autonomous way it is lagging. Something around 2 lakh lines of software. And it has to work in a complex environment. Lot of things it has to be done. But God has given you a brain. Simply, I think about your director, entire chronology of events, when everything will come in the screen. If I think about my mother, the entire thing will come in the mind. Yeah. So when you think about, simply think about my friend, everything will come. Such a fantastic computer. It will be lakhs of memory compared to a Chandrayaan 2 computer or Chandrayaan 3 computer. And the neurology department where he is leading, I don't know. Even we could not imagine how they do the surgery, what they do, how they understand such fantastic job people are doing. And really, let us give a big hand to all the people who are responsible for the medical field. Probably when you appreciate our, not underestimate the medical field. It's a very complex machine God has made, and you people are responsible. Coming to BMT wing, your contribution is a world story and world history. A human pump, heart pump. 40 years back, we were trying to, as a student, I was trying to understand how it was working. Very difficult to understand. You have developed a heart pump with low cost, and you have so many transplantation. I think how many people you have served. I let us give a big hand to BMT wing also. Not only this, for your entire activity. And now coming to my talk, I don't know. For this audience, we are supposed to talk a little bit medical field, but I'm not a doctor from that profession, a doctor in aerospace. So when you were director in the ESIC conclave in Delhi, he met me, he told, sir, you have to come and give a talk. Then I was thinking, sir, I'm not a medical doctor, what I'm going to talk, and I'm not a specialist in any field. Then finally, we convert that, I will give you a talk on this Indian Space Research Organization, the milestone, the future. And my structure of the presentation is, I will give the overview of the evaluation of Indian space program, summary of accomplishment achievements, and approved program and the space mission 2047, space sector reform, what it has brought to the common man of the country, and targets and the way forward, and ISRO's little bit contribution, with my LKG started knowledge in the understanding, I would like to just talk a little bit on that field. And along with that, generally, your director is one of the person God has given a gift. His thinking and communication, there is no gap. synchronized way it will go, but we are all not that good. So in order to make this little more memorable, at the end, we are going to show a video of some 11 minutes. The ISRO Indian Space Program, I think these are well known. Is Sarabhai, the father of Indian Space Program, who initiated or rather started this activity. And at that point of time, there was no human spaceflight activity, nothing. It's only how to bring advanced technology for the benefit of common man. To do that, three things are required: space technology, we need rockets. First of all, we need satellites of different classes, different types. And to place the satellite, we need launch vehicle. Then we need ground segment for sending the satellite in the appropriate location and appropriate place, also utilizing the satellite data. So all these developments started concurrently. And if you see historically, something you have to do, otherwise the screen, something is happening. My throat is also not happy.
Yeah.
So I think this slide may be known to you. 1962, the entire activity was started, and we all are so blessed and privileged. It started in Thiruvananthapuram in a church building, and there are major milestones in the activities. It was 21st November 1963, the first tiny rocket lifted off from Indian soil, and 1916 ISRO was formed. 15th August, very easy to remember, and 72. Initially, for 10 years, the activity was under Department of Atomic Energy, and then it shifted to a separate department called Department of Space from 1972 onwards. Okay. Something is wrong. Oh, fine. Now, if you look at the activities, directly it is coming under the department, coming under Prime Minister of India, and we are having ISRO with 13 center and units responsible for the design, development of rocket, spacecraft, and application. And we are having autonomous bodies, including IAST and the Federal Physical Research Laboratory. And we are having a system called InSpace for promoting and holding and authorize private space activities. Then we're having a commercial being also. We have got 43 offices located in 22 locations of the country. And our annual budget is 30,500 crore with a sanctioned manpower of 20,000. We are strongly supported by 450 Indian industries throughout the country and 130 academia from the country. And coming to activities, entire activities are carried out under 6 verticals today. The rocket and related technology under space transportation system, satellite in the under space infrastructure, space application, human flight program, capacity building, and sciences. Now, the entire accomplishment and achievements, before I go, I have to just tell you, 1963, November 21st, when the tiny rocket lifted off from Indian soil, this rocket was given by USA, a small rocket. And application, exactly 50 years back, 1st August 1975, we demonstrated mass communication through satellite system, keeping 2,400 television sets in 2,400 villages of 6 states in India. And for that, a satellite signal was required, and ATS-6 satellite belongs to America. They were ready to give the satellite signal because at that point of time, probably they thought that we are LKG standard and they are on the PhD level. That's true. We were 60 years behind them. 1969, when it was formed, just we are making small rockets and exploding, all the motor explosion. And the Neil Armstrong successfully landed on moon and he has come back safely. Then you can understand the type of gap. And from that beginning, from that era, to this year, July 30th, we accomplished an important mission called NASA ISRO Synthetic Aperture Radar Mission, a satellite. The 10,300 crore is invested by America, JP America, for building a payload and the antenna. And a similar payload with almost 1/10 the cost we realized. But we don't tell outside, we realized S-bands are payload. And then entire satellite, when you talk about satellite, there are 33, 40 systems. Entire satellite was built by Indians in India and launched by Indian launch vehicle precisely in the orbit. Thereby, when we started with the LKG game, today we are rubbing shoulder to shoulder with the developed spacefaring nations by this accomplishment itself. And that is the type of growth what has happened. Now, whatever has happened over 63 years of accomplishment is put in this slide. And from the first tiny rocket till today, 4014 sound rockets are lifted off from India. And we have realized and developed 6 generations of launches, satellite launch vehicles. And the first vehicle was successfully demonstrated in the year 1980, the SLV-3. It was 35 kg Rohini sounding rocket in space. And the project director of that project, SLV project, was none other than A.P. Abdul Kalam ji. And from that, we have come a long way. Today, our Bahubali rocket Mark III is capable of raising 10,000 kg to low Earth orbit. That is the capability what we have come and we have accomplished not 1 or 2, 1 or 3 missions. Coming to satellites, it was 50 years back, 19 April 1975, the Aryabhatta satellite was built to support of USSR and placed in orbit with their support. From that till today, 133 satellites of various types for remote sensing, communication, navigation, space science we have accomplished. And also, in the area of space application, I have another slide. Lot of 50 applications are there. And 433 satellites of 34 countries are lifted off from Indian soil. Until today, that is the type of accomplishment what is done. And now the space sector is going exponentially. You can see the curve. Compared to last 10 years, this 10 years, it is doubling in terms of rockets and satellite, and similar things are happening. Coming to application, actually this slide alone, one can talk 5 hours. There are 50 applications, and I have put in a single slide, starting from 1975. The last 50 years, there are 50 applications. The area of Earth observation, ensuring food security, water security, ocean application, potential fisheries zone monitoring, and meteorological application, risk management, and television broadcasting, education, search and rescue operation, telecommunication in that area. And 10,400 trains today we are monitoring real time. 10,400 trains. And then disaster warning mitigation, we are doing a lot of service and strategic application. Now, if you take one example, train tracking. You know, some 15 years back, if some of our relatives are coming to Trivandrum by train, you know what was the way of communication? You will get an inland letter stating that are coming by this train. And I've also gone and received some of the guests. When you go to the railway station only, they announce the train is coming 3 hours late. What do? You cannot come back and go. See there, take a cup of tea, wait there. After 2 hours only, second train will come. Next, another 2 hour delay. And you sit there and enjoy the railway station. And what else you can, and today, that is not the situation. You can monitor where the train is coming, when it will reach, and can reach. And disaster warning mitigation. There was a time if disaster happened, even the Orissa cyclone, 10,000 people passed away. And take the tsunami, 2005 tsunami, so many people we lost. Like that, every disaster we lose a lot of people, but today, not solve the problem totally, but then early. Things are under control, but a lot more things has to be done. In the area of telecommunication, I think the younger generation, we are all jealous of you. You are all lucky people. Any connectivity, next minute you will talk USA, Russia, anywhere you liked. But you know, when I was doing my MTech in IIT Kharagpur, to make a phone call, it will take 2 hours. Go to the trunk, wait in the queue, and then somebody will dial and give. And most of the time, hello, when you start, it will get disconnected. And I have faced one time, once it gets disconnected, my friends will not allow to stand and redial. They will say, come back in the queue. Then you come back in the queue. And this process continues. But today, that is not the situation. I think this space has done a lot of things. Television broadcasting, you know, there's a program called Chitrakar. Chitrakar, who have seen? Oh, backside, sir, they are not understand us. Only 5 songs used to be played every week. If you miss Friday, you have to wait 1 more week. And 1 more week, you know, how much time? 7 days into 24 hours into 3,600 minutes. So much time you have to wait, then only you can get another song. That's the place. And ensuring safety and security. You know, recently, Sintur operation, Hope you're okay. Lot of our satellites have worked perfectly well. Perfectly well. No problem. It was perfectly worked. And so lot of applications. And in spaceman, till today we have accomplished 10 missions. Chandrayaan 1, we have found water molecule on them. Then Mars orbit mission, we have accomplished this mission traveling 68 kilometers and succeeding in the first attempt. India is the only country, first country succeeded in the first attempt. No country has succeeded in the first attempt. And 68 kilometers when you travel, please do a small calculation. 0.01 the error if you travel. Where you will reach, you cannot go to Mars, you will go some other planet. But we've gone and we have succeeded. And then like the Astrosat, almost 10 years it is working, Aditya L1. There are a lot of things happen in the area. Now, in the initial phase, if you Google, you get one fantastic photograph. In the initial phase, I was thinking it is artistic photograph when I joined. Our people used to move rocket pods in old bicycle, not even brand bicycles. And from that era, today, 10 places we are number one in the world, 10 places. Chandrayaan 1 find water molecule along with USA. We are the two countries which can be proud of finding water molecule on the moon. Mars orbiter mission, we are the only country and country succeeded in the first attempt. None of the developed countries has succeeded in the first attempt. And Russia placed the first satellite, Sputnik, in 1957. And then to their record, 37 satellites using a single rocket they placed. We debated in Thiruvananthapuram how to break type of world record, and the addition came. We will place 100 satellites, and 100 satellite placing is easy. 100 satellites, when you put it, hit each other. And finally, dear friends, it is history. India is the first country which succeeded placing more than 100 satellites using a single rocket. And we are having that world record. Today, of course, somebody else has taken over. Doesn't matter if we can place 200 satellites also. And Chandrayaan 2, who is having best camera in the moon's orbit? Which country? India is having the best camera in the moon's orbit, 32 centimeter resolution, and the best photos belongs to us. Chandrayaan 3, we are the only country and country succeeded soft landing in the south pole of the moon. And solid propulsion, when I joined ISRO, my boss used to tell, we make solid motor, most of the time they explode those days. And Mark 3 rocket, it's a Bach rocket, we are having 200 tons, 207 ton solid motors. Only 2 motors were tested and we went for the flight. Other countries like 7, 8 motors, static tests, then only go. In fact, I understood the importance of us when I was not in India. After this experimental flight, I have to be in France. They wanted to know how was performance of this motor. I didn't know why they were interested. I had a half I sold. Then both motors one or another performing. Then only they were surprised. What you people are doing is too static to such a performance. So it is a record for us. And cryogenic rocket engine, a technology which was denied. When you talk about cryogenic rocket engine, what for it is? I'll tell you 1 or 2 examples. Aircraft engine, you all know. To develop a 20-ton thrust by aircraft engine, 1000 kg per second of air and fuel has to be used. Whereas same 20-ton thrust is generated by a cryogenic engine utilizing 45 kg per second of liquid hydrogen and oxygen. I think you can understand the complexity and comparison, And same way, this engine has to give a speed of something 17,000 km per hour for placing Chandrayaan 3 in the orbit. For placing Chandrayaan 3 in the orbit, we need almost 27,000 km per hour. 50% has to be given by this engine. And this technology was denied to India. Today, thanks to those countries which denied, and we have developed real 3 cryogenic engines. And in that development, we are having 3 world records. And minimum time for the Mark engine from the test to flight, we done minimum time. We are having 1 world record. And a stage level test in Mahendragiri, we have done 34 days using 5,000 kg of explosive hydrogen. Other countries, minimum time was 60 days. And average 6 years. Sorry, average is 1 year. And like the 3 world records we have made. And of course, we are in the process of making lot of world records further. Coming to global leadership, 50 years back, 55 years back, we don't have any satellite technology. And thanks to Honorable Prime Minister of India, when he was the Prime Minister of India, we were given a direction to conceive and build a 1000 kg communication satellite. And we built, launched, and donated to South Asian countries. That is the type of growth what has happened. Today, we are building a G20 satellite for G20 countries, and India is the leader building that satellite. Almost 70% work is ours in satellite. Also, we are going to launch. And we strongly support our neighboring countries. And Chandrayaan 3, you know, we are working on Chandrayaan 4. Chandrayaan 4 is a satellite which is meant for landing on the moon, taking sample and coming back and doing experiments. So that is the work we're doing. By 2028, we are targeting that launch. Lupus. Chandrayaan 3, when we landed, you all know there was a rover which came out, it was 25 kg. And in the Lupus, it is a joint collaboration between Japan and India. You know, there is a statement, strength only respect strength. When we succeeded, Japan wanted collaboration. We are building a 350 kg rover. And Chandrayaan 3, lander mass was 1600 kg. Here, lander mass will be 6500 kg. And Chandrayaan 3, the life was 14 days. Here, it will be 100 days. And we are working together. Again, this mission will be accomplished in 2028. And till today, we have done something around 14 dedicated commercial missions. And a country which is not knowing what is satellite, what is launch vehicle, 433 foreign satellites we have launched. And you know, the launch vehicle, the T-body rocket, how many people have used T-body rocket? I think most of you would have used it. What is this backside? You are not enjoying life, what? And everybody would have done, you know. And T-body rocket, when you hit 30% time, it not work. The CORC rocket, 20 to 30% it doesn't work. Even if it works, it will go wherever it wants to go. And whereas our launch vehicle should go wherever we want. For that only we all are working. Unnikrishnan Nair, DK Singh, V. Narayan, all toppers from the respective colleges, we are all working. And I had a very bad experience. Last year, Deepavali, I got some crackers and some 10 rockets of 700 mm height. And we are staying in a apartment in a place. 10 houses are there and one 9-story building is there. And only vacant plot. When I bought this, my wife asked, what for you are doing? You are a rocket scientist for these rockets. And I told, okay, let it be there. And then I asked my son to lit the flame. He told, what nonsense, so many houses are there, something happens, I will hold responsible. No, I will not do. Finally, it was the fact, not this year Deepavali, last Deepavali. There is an apartment there, there is a vacant plot. I broke one glass bottle, kept the rocket, exactly opposite direction of that apartment, and put the, rocket nice. I don't know what happened. All of a sudden, 180-degree turned and went and hit the 7th story window. And we are seeing the family sitting and talking, and my wife was, rocket sound was less. Her sound was much more than that. Shouting, what nonsense you are doing, and hitting somebody's house. Simply until everything came inside the house. And so this is the thing, but our rocket should go required a bit. For that only lot of things has been done. And this year, lot of accomplishments. And we have done a docking experiment, space docking, 2 satellite rotate with 28,000 kilometers per hour. We have to successfully dock in space. If it is so simple job, every country would have done. We are the 4th country which has succeeded so far. That means you can understand without hitting, you have to align in the space, and finally you have to dock. And first satellite launch vehicle mission was done in the year 1979. And it was a partial successful mission. This year, January 20th, the 100th launch was there. And fortunately, after I took over as the chairman, the first launch. In any house, after the wedding, I don't know those who are here, the old days. Nowadays, nobody talk anything. Old days, after a marriage, if immediately after the marriage, if anything wrong happens in the house, who will be blamed? The daughter-in-law will be fairly blamed. She's the culprit, because of her only things happening. Here also, after I took over, this is the first launch. If anything goes wrong, what will happen? So this fellow, unlucky or whatever name, and first mission failure. But I want to tell this history. It is a team, my team, the entire Inauguration. I was the director of ESS. responsible for the launch vehicle and satellite, lot of things. And finally, we have successfully accomplished the 100 mission and written in the gold letters of Indian history, the 100th launch was perfectly successful. And next one, Axiom program, and Subhash Shukla, probably you all may be interested to see him also. And he is the second Indian and first Indian sent to International Space Station. And he has come back safely. He has done a lot of experiment. Here also, one of the contributions from Indians were the rocket was supposed to lift off on 11th July. And finally, this one happened on 25th July. And we came to know decasing I was there, one Mr. Mohan at LPC was there. We came to know there was leakage in the rocket, and rocket was clear because people thought it's a minor problem and it was clear. And we debated, discussed, finally, we went ahead insisting for stopping the rocket and correcting leakage. And initially, we were feeling very bad. These Indians, what they are doing, unnecessarily they are stopping. And finally, it was called off. And when they went and inspected, there was crack sitting there. Finally, everything was corrected. And today, I am proud to say that Indian education system, Indian ISRO training has proved that we are second to none, even in stopping a human-rated vehicle in the last minute for ensuring safety of the astronauts. And coming to Subhash Shukla, he has done a lot of experiments, 7 experiments. It is not only he has done, so many 7 teams have enabled him to do the experiment. He also did his part in space. One of the things is the regeneration of the muscle. You know, under space environment, a lot of things happen to muscle. And some reagents were used. Of course, the data will be published in the appropriate time. And we have understood, yes, the muscle regeneration can be minimized using appropriate things, like a lot of things are done. And these are all the experiments, probably want of time. I'm not going to dwell because this itself is a full day talk. The 7 experiments, what are all its outcome. And NASA ISRO static aperture radar, as I told, please understand, 40,000 crore is the type of satellite when launch. Either it will go to space, if you do a mistake, you know where it will go. And 14,000 crore, what people will talk and what type of pressure on us, you can understand, you know. But it was perfectly launched in the triggered orbit. And then recently, this month on 2nd November, we had an important mission, the communication satellite 03. This is the heaviest communication satellite ever lifted off from Indian soil, a 4,410 kg communication satellite meant for strategic application. If the satellite is not there, the communication strategy purpose will be having a problem, and we are perfectly placed. Today, the satellite is perfectly working, and we are going to declare operational shortly. And again, program, I think there are 2 directors sitting there. The founder director, Nilsson Nair, and then the current director. And, you know, this is the place to send our own Gaganyatri astronaut to space and bring back safely. Actually, sending somebody is very, very easy job, but bringing them back safe is a very tricky job. So everybody is working towards that. Around 8,000 tests are done till today, and lot of work has to be done. For example, if you have to take human being, you have to maintain pressure, temperature, relative humidity, carbon dioxide, and everything has to be maintained. We call it as environmental control and safety system, this development. And in case any problem to rocket, we cannot lose our human being. You have to save them. So there is a crew escape system developed. And the rocket itself has to be human rated, bringing lot of redundancies and margins. So that has to be done. And then towards the end, they have to safely land using a set of parachutes. Recently, we demonstrated a parachute experiment. Very easy to say, but so much work has gone. 24/7 work is going on. It is not only ISRO project, it's the entire country's project where Navy is involved, Air Force is involved, DRDO labs are involved, ISRO is involved, academic institutes are involved. Lot of work is going on. And we are targeting this flight by 2027. Sending our own human being to space and bring them back safely. Before that, there will be 3 uncrewed missions. And after that, also a lot of activities are there. And India is going to build its own space station called Bharat Inauguration. It is a 52-ton mass which has to be lifted and placed. And it will have 5 modules. And first module, we have got the project approval, and we are going to accomplish 2028. In fact, I have put a like decasing nicely, put the job on your director, I put the job on somebody else. Our former chairman, Somnath sir. So I have put this engineering design on his head. You please review and give the guideline. So he is fully working. And he means it is a teamwork. ISRO has to work. Finally, he has to review. So we have dumped the job on his head. And then I'm sure with the type of our citizens, our education system, our knowledge, we will build the space station at least 5 years before 2035 and we'll complete the station. Here, I used to always think when you put, I am from a poor village, to be frank, poor village and poor family. Okay, but when you put this type of thing, some 20,000 crore you spend, and you should get some justice, should get some benefit. That's a place probably Chitra can debate, discuss, and come back with microgravity experiments. Whatever possible, please discuss and come back. We are there to execute on free of cost. And of course, this experiment, not only this, manufacturing, biomedical, then medicine development, lot of things can be done, but one has to do literature surveys. Put a team, let them do literature survey and come back what can be done so that some useful proposal can come. And Chandrayaan 4, Chandrayaan 5 already I have talked. And Honorable Prime Minister, highly ambitious and very, very smart and outstanding personality. And he given a direction, simple direction. Why don't you land man on moon and bring them back safely? Very easy to tell, what is involved. Our first large vehicle, the capability is 35 kg. And the current vehicle, what we are having, the Bahubali rocket Mark 3, which has lifted Chandrayaan 2, Chandrayaan 3, so many things. The capability is 9,500 kg. We have to build a rocket which has to lift 80,000 kg satellite and place in the orbit. And the rocket we have conceived, it is equivalent to 40-story building height. I think Trivandrum, we are having 11-story building height, if I'm correct. This is a 40-story building height rocket. And, it's a 40-story building height rocket, which has to lift it off. And already we have conceived this configuration. And of course, we have to go through the review process and we have to do. And 2040, we have to land on the moon. If 2040, we have to land on the moon, by 2030, we have to make it ready. Then only we can do a lot of unmanned missions, then we can do, but we're working towards that. Towards that, lot of new technology developments, including propulsion, navigation, lot of things, activities are going on. Venus is another planet we are interested. We have got a project approved and we are going to accomplish a mission again 2028. Mars landing mission, we are working, configuration is ready, report is ready. By 2030-31 time frame, we are planning to accomplish that. And we are improving our capability of the launcher without increasing the cost. For example, present Mark 3, 4.2 ton GTO, equivalent LEO is 10,000 kg. That we want to increase 25% without increasing even 1 paise of the launcher cost. For that, we are developing new propulsion system, including liquid oxygen kerosene engine. A 200-ton thrust engine we are developing using liquid oxygen and kerosene. And lot of achievement has happened this year. And in another 2 years, you'll come to know that India has succeeded this program. And we are working on the air-breathing propulsion. We are working on reusable launches. And, one day, I will tell you, 6 years back, I was so tired returning from my office. Night 10:30, if I'm correct. I have an exact time and other thing, date in my diary. When I came back, my son was sitting. He was in the 8th standard. He was telling, the moment I entered, he told, please wait. He showed one video. And I was surprised to see the video. The video was nothing but SpaceX landing back. He told, when are you going to do these type of things? Then I asked, hey, how you land? Somebody went to the St. Thomas School, they presented. And then that has come in the YouTube, just downloaded and he's showing. And, showing very easy. We are all working towards that. Lot of experiments are done. Coming years, whatever generation vehicle, what we are talking, we are going to recover the first stage, but a lot of work has to be done in that area. A lot of things are done. And advanced propulsion, there was a time air travel was so interesting, but nowadays it is so boring. Every day, alternative day, we are traveling to Delhi here and there, 3 hours, 3.5 hours. So, and going to USA, 20 hours you have to be in the flight, right? And the very tedious travel. One of the area what one can do is the combined cycle engine. where the aircraft engine will take off. After some time, bring the cryogenic engine into the loop. Bringing the cryogenic engine, you can reduce the travel time. There are associated problems like noise, other things. So we have to put those things in the closed loop so you can reduce the travel time. And here we have just initiated the activities. Some 50 engineers are asked to study the literature survey and they are working. But long way to go. Surely there are technology intensive and lot of opportunities are there in this area. And we are working on multiple areas, including the Chandrayaan 3. So much work, finally the life was 14 days. What was the reason? After landing, 14 days it is exposed to sun. Another 14 days it will not be exposed. So when it is exposed to sun, electricity is produced and the entire system was working. When it is coming the shadow region, it cannot work because it will expose very deep space conditions and the entire electronics gets killed. And to survive it, make it survive, we have to put radioisotopic heaters. So already in the process of developing, these are all the confidential things. Another thing is nuclear thermal propulsion and quantum communication and a lot of areas you are working. This particular slide, what you are seeing is a single slide, the outcome of something around 4,000 page report. The entire R&D activity of ISRO is put in some 4,000 pages. From that, I thought I should put 1 page only. This is the outcome of that. So lot of R&D activities are happening in new technology development, including reusable technology, quantum key distribution, on-orbit refueling. One of the, whenever you drive from here to Chennai by car, can you imagine? The moment petrol is over, somebody stopping and buying another and going. Can you imagine that? Here, today, same things happen. Put a satellite, once fuel is over, you have to send next satellite. Instead of that, you refuel. Like that, you refuel the car and drive. So that is one of the technology we are working. Like that, lot of new technologies and artificial intelligence, data science, whatever talk, current engineering, everything we are working. Sector reform. Today we are having 57 satellites in the orbit. This now has to increase to 3 times, which is not possible only by ISRO. So Honorable Prime Minister rolled out the space sector reform. So we are hand-holding private companies and startup system, work on space in the area of launcher, satellite technology, utilizing the satellite data. Satellite data, one I want to tell. There was a time, and due to some flood or something, if you lose your paddy or wheat, and you have to claim the insurance, what is involved? You have to go to the insurance company, then somebody has to come and see. And whether he is seeing the right spot or not, God only knows. And finally, it takes a lot of time. Today, using satellite data within fraction of a second, you can understand what happened before disaster or after disaster, you can get it released. And how huge data is there. Today, our friends in the private sector, they are working, showing to insurance company, look, this was the paddy field earlier. Now this is the question, please release the thing. So like that, lot of work can be done. So space sector reform, you have lot of things. And earlier, Tarabai vision, there was no human spaceflight program. And it was for utilizing space technology for common. And when we reviewed at one time, we were very bad at the space business. Of course, that wasn't our interest. Our interest was to bring advanced technology to the common of the country. And today, when the assessment is made, out of $450 billion, only our share is hardly 2%. And this number has to be taken to at least 8-10%, and we are working towards that. And there, the space sector reform really help. And what number is there, from $450 billion today total space economy, it is going to increase to 2030 by 612 billion. So 8% of the 612, we want to get our share, market share. Right now, our share is hardly $8.4 billion. And this number has to go to some $50 billion. And it is very, very difficult job, and we are working towards that. And lot of activities we have done even this year. There are 68 Government of India departments using space data. And all the state governments are utilizing space data. So we had a meeting. I will tell you, in 2.5 months, 300 plus meetings were conducted, and we have completed the requirement of everything, 90 requirement documents, each 200, average 200 page. Remote or? Now, space medicine is yet another important area. You know, when an astronaut goes to space and getting exposed to microgravity condition. In fact, I was trying to read. Sometime back I was working as the certification board chairman or human spaceflight program. And I was trying to understand, you know, how much literature is available. Thousands and thousands of pages of literature is available. How the fluid flow happens, and what type of problems are happening to eye, what type of problems are happening to muscles, and what is happening to tissues. So many research is going on, and lot of things has to be done in that area, and that is the area in which we want lot of your contribution in that area. And another important area is National Health Resource Repository area. And ISRO has contributed in a big way, developed Android-based mobile app for collection of health resources, assets detail, and one platform to receive mobile geotag data. And it is one of the area really we are contributing. Another thing is Bhuvan, e-herbs. In fact, I want to tell 1,880 herbal gardens is totally mapped by our Earth observation satellites, and we have loaded. And I was also wondering, in fact, we are having some land near Nakoil. My father-in-law has to put lot of medical plants. His plan was originally, his entire service investment, including 5 years, he was working in USA, whatever saving. And here, 40 years, he worked anything, plus whatever property he had in Toronto, everything sold, and he has invested near Nakoil, and he has planted lot of medical plants. And like that, so many people have planted. In fact, we want to understand that also. I am taking project to understand how much medical plants are there. And this is one of the area we are contributing. All urban gardens, we have this one, and we have validated the data, and we have loaded. And from that we can understand, you know, what type of plants are there, go to the field and try to validate. And this is already loaded. And again, vector on disease monitoring, forecasting. No, this once this type of disease spread, you know what will happen. I not explain to this, and only satellite data is possible to really understand. And in this area, we are doing lot of work, remote sensing data, image classification, and finally understand what type of things are happening. And this is one area we are working. Another one is early warning of vector-borne disease. In fact, I want to tell, not talked about vector-borne disease. Probably the youngsters cannot understand. When I was a fifth standard student, 5th to 10th standard, there was a season in which cholera disease used to spread. I don't know how it is coming. Can you imagine my neighboring village, single day, 12 people passed away, single day. And we were worried. We cannot move from our village. What is happening? What is the reason? How it will spread? And this type of things, if anything is happening, anything is going to get spreaded by either bats or animals poorly, satellite data can really do great job. And climate and environmental monitoring, actually, the satellite data are sometimes it is also really disturbing. I had the opportunity to see the environment of Delhi quite often seeing the satellite picture. If you see, you will be afraid of going to some places. But today, it's the fact that we are in a position to understand what is happening to air pollution, and G20 satellite is also going to contribute in a big way. In fact, every city, every area we can monitor and we can tell what is happening through our. Actually, otherwise, humanly it is impossible. Without satellite picture, it is impossible. And water quality assessment, you know, most of the diseases are getting spreaded because of bad water quality. And the space can do great job. We are doing a job. In fact, we can monitor and understand where stagnant water is there and what type of things are happening and validate. And this is one area probably we are in a position to, we can contribute here. And this is another important thing. I think the credit should go to the Vikram Sarabhai Space Center. Lot of work done in this area, ISRO Smart Limb. In fact, there is a model available, probably one model we have to give it to Srichit also. You know, to make this, we were understanding that time only. Say, simply you are walking and when you go, you don't understand what type of complex mechanisms are inside when you walk. And when you try to make this, when you understand what are all things really involved to make it, include the materials development, then the mechanism development. And in this one of the area, really we have lot of good job. And medical ventilators, when the COVID pandemic spreaded, I want to tell 2-3 places we have contributed. In fact, I want to tell from my own village, one young woman, age of 27, 28, our own distant relative, for water of half liter of medical oxygen, she lost her life. To hospital, no ventilator, no medical oxygen, moved to another hospital, on the way passed away. And we have supplied, we operated, we are having a medical plant in Mahendragiri, 600 metric tons of medical oxygen we continuously produced and supplied to the states. And another area where we took the initiation was developing ventilators. Actually, we are not the people who can put trials. Unless a collaborative effort is happening between medical fraternity and ourselves, this cannot go in a way. But then lot of work is done in this area, both VSSC and PSC. And of course, this is LVAD. It is one of the area when we can develop heart pump. I mean, when we can develop that pumps for liquid engines. This is one of the area we have done lot of work, but lot more can be done. But it can be done together. And Chitra, 20th April 2025 is the historical day, which I will not forget, hope you will not forget. And that day we have signed, and thanks to your director and all the people here. And DXing, I have to put lot of questions so that he will escape from Bangalore and land here. So that we have to do. And today, really, initiation, a humble beginning. Who thought when we were moving our rocket in old bicycle, we will make world records? Same way, today probably like baby step you have started. I request the director, both BMT Wing and Sri Chitra, to do one thing. In this area of medical science, at least in another 22 years, we have to have 5 world records. Please work towards that. Don't repeat something that is done by others. Please work towards that. Funding problem, whatever is required, we are there to support. Moral support can give, but only you have to work and we have to do. Sir, we have to put a target, at least 5 world records we must get in 22 years. That let us work towards that. And coming to Indian space, we are working on Gaganyaan, and we are working on our next generation launcher, and we are working on the Bharat Energy Station. We are working on moon, the crewed mission to moon, and a country started the game, we old bicycle, and we moved our first Apple satellite, the first communication experimental satellite in Bangalore, experiment in old bullock cart. And from that humble beginning, today we are having world records. We are rubbing shoulder to shoulder to other developing countries. Next month, we are going to launch a 6,000 kg communication satellite of USA on purely commercial basis using our rocket. That is the place we come. And by 2040, from that cycle era, we will be in par with any other spacefaring nations in terms of launch capability, satellite technology, application, human spaceflight program, whatnot. We are going to contribute for the Viksit Bharat 2047. And before I conclude, I have got a request to this medical fraternity. When we are working like this, 2 requests. Number 1, we want you to be with us. When we talk about human spaceflight program, lot of collaboration has to happen and we have to work together. This is one request. Second request is the healthy life of Indians should become 100 years, not life of Indians. If it is life of Indian 100, then there is a headache to the country. It should be the healthy life of Indians should become 100 years for that whatever is required to do. Thank you, Jai Hind.
Thank you, sir, for that inspiring address. May I request our actor, Dr. Sanjay Bihari, to present a memento to honor our chief, Dr. Narayanan.
Before we conclude, that video also you are going to see. Sir, shall we wait for this memento? And please show the video, maybe 10, 12 minutes. So that whatever I have talked, you will be a flavor of it here in.
Volume, 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 volume.
Space is wonders that fuels up humanities and just urges to explore, a cosmic theory of planets, stars, and dazzling mysteries. His brain has for individuality, unraveling universes, secrets, was the unspeakable curiosity, and an insatiable discovery. Connect its journey into space to 1930s, to the time when some applications were still in experimental phase globally. Dr. Vikram Sarabhai, true visionary of India's space programs, firmly believed that space technology could be harnessed to address society's challenges. The Indian Space Research Organization, established in August 1969, subsequently on the Department of Space in September 1972. The main of ISRO is the development of advanced space technology and application of space technology for societal, commercial, developmental, and strategic requirements of the country. 50 years ago, India built its first satellite, Bhatta, that was launched with the help of Russia, erstwhile Soviet Union, on April 19, 1975. Marking India's entry into the select club of spacefaring nations. Satellite Instructional Television Experiment, SITE, an experimental satellite communication project jointly designed by ISRO and NASA, was launched in India during 1975 to promote informational television programs in rural India. The largest social experiment to educate financially and economically backward community. Since then, 132 satellites have conceived with state-of-the-art technologies and launched for communication, Earth observation, navigation, scientific applications, etc., for the benefits of humankind. Some of the major space-based services are telemedicine, teleeducation, disaster warning, weather forecasting, resource management, planning, etc., addressing civil requirements. From the nascent phase of transporting our first indigenous communication satellite, Apple, Iron Power Payload experimental satellite, today we have established state-of-the-art facilities and proven our technical prowess in the field of launch vehicle capability. From the major challenge of having no access to cryogenic propulsion technology affecting its ability to launch communication satellite. India overcame these challenges through successful demonstration of GSLV mission. Augmented to this, India developed and qualified a new cryogenic engine 3 times the thrust for an LVM-3 launcher in record time, setting 3 global benchmarks. These include completing development and flight with just 3 engines, achieving a maiden flight in 28 months, and conducting the stage hot test in only 34 days, faster than any other country. We aim for many such records to be made in the coming years. India achieved its first successful launch to orbit with SL-3 on 18th July 1980. The nation developed 6 generations of launch vehicles with advanced inertial and navigation systems, SLV-3, ASLV, PSLV, GSLV, LVM3, and SSLV, and recently achieved the milestone of 100 launch in January of this year, the launch of GSLV 15.
This mission is the 100th launch from our launch pads, which is very significant milestone of India. Our space program was conceived and started visionary leader Professor Vikram Sarabhai and taken forward by generations of leaders.
Fact, half of these launches were accomplished in the last 10 years alone, indicates that our space sector has grown exponentially. India has demonstrated a unique approach for its space science satellites. The high success rate and the cost-effective nature of our lunar Mars missions have caught global attention. India's first lunar mission discovered water molecules on the moon. The second lunar mission, Chandrayaan-2, has the highest resolution camera, 52 centimeter in the world, that continues to map the moon. When Chandrayaan-3 satellite became the first satellite in the world to touch the south pole region of the moon, it also touched the heart of every Indian, and the whole world watched and hailed the achievement. India became the first country to successfully insert a Mars orbiter on its maiden attempt in 2014, which also made a record as cost-effective mission. In 2023, it launched its first lunar mission, BTL-1, becoming the fourth country to do so, with the spacecraft now actively contributing solar data to the global scientific community. Indian space sector reforms aim to foster private sector participation and innovation in space activities led by InSpace, the support of ISRO and INDL, through handholding and enabling the non-governmental entities, NGEs. This year, India will witness the first commercial launch vehicle, PSLV-1, realized by industry consortium, carrying ISRO technology demonstration satellite TDS-01, demonstrating host of new developments such as indigenous fueling, tube amplifiers, etc. Today, we have a world-class ground infrastructure in the country, distributed across various states, including multiple launch pads, engine and stress testing facilities, and ground tracking facilities, including a 30-meter antenna for space exploration missions. ISRO is advancing quantum communication technology to ensure ultra-small satellite-based data transmission in India. As part of our capacity building outreach activities, ISRO adopted multi-pronged approach such as establishment of Indian Institute of Space Science and Technology, IIST Regional Center, delivering space-based courses, etc. Recently, as part of the historic Axiom 4 mission, Gaganyatri Subhanshu Shukla etched his name in history, the first Indian to board the International Space Station ISS. Another major endeavor is ISRO Drax mission to Moon, Chandrayaan-5, LUPEX mission. The Indian space program has set its sights high in the next 25 years with a Gaganyaan program.
2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा जो हमें स्पेस के अज्ञात विस्तार को जानने में मदद करे.
The first mission for Gaganyaan is planned this year to demonstrate the associated technology for human space flight. ISRO has initiated development of a super heavy lift rocket to take our Gaganyatris to the moon and back. Various initiatives in the space sector and the goals identified under the Space Vision 2047. We elevate Indian capability in launch vehicles, satellites, and space applications on par with the leading spacefaring nations by the 2040-45 timeframe and contribute to the goal of Viksit Bharat by 2047.
May I request our director?
Sir will give, but sir has to just leave. So I think we should give ISRO and sir and everybody, the directors and the entire team a standing ovation. I think that
I invite Dr. V. Narayanan to kindly accept our token of appreciation. I invite Dr. Unnikrishnan, former director, BSc to Random, to accept the tone of appreciation. May I now invite Dr. Harikrishna Verma, Head Medical Technology Wing, to propose vote of thanks.
Professor and most respected Professor E. Narayanan, the Honorable Secretary of the Department of Space, Dr. Dinesh Kumar Singh, Honorable Director of the Human Space Flight Center, ISRO, our beloved Director, Sanjay Buhari, all esteemed guests, dear friends. This, as you all know, that's a proud moment for all of us who has gathered here for this auspicious occasion on the inauguration of 2 new facilities and launching of the new academic program on bioinformatics. Needless to say, the launching of these facilities and the academic program is a milestone in our history of institute, and because of its very unique nature. As you all know, the Indian Space Research Organization, Department of Space and CTMST has signed the framework memorandum understanding of the cooperation of space mission in 25 April 2020, which marked the significant milestone in the achievement of space medicine and its application in this country. with formal inauguration of the Center of Space Medicine and Research, and with the support of CSRO, so the clean room and some microgravity and other activities also will be coming in the days to come. So it is my honor and privilege to thank the most distinguished person of this day, Professor V. Narayanan, Honorable Secretary of Space, Department of Space, and for inaugurating both our facilities as well as for launching this new academic program. And you all know that, how simple he, as a person, simple as well as so much complex technology has been explained in a very, 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 very jovial way. At the same time, we are all proud of the whole work of the contribution of ISRO. So on behalf of all of you, I thank the whole entire ISRO, Professor Narayanan and the team for making this today as a very memorable one. Dr. Dinesh Kumar Singh, I am extremely happy to visit their entire facility in the facility of HCC, which is a very important and unique facility for the human space program. And he has also played a crucial role in the ISRO of this space program missions, including training of the astronauts and developing necessary technology. So we will also be, in the coming days, we will also be contributing our own way for this successful missions to come in the future. So once again, thank Professor Dinesh Kumar Singh and the whole team from HSCC for coming out today. And our thanks goes to our director. So he has initiated several, as you all know, that several programs and which is taking in the different levels. So on behalf of all of you, I thank him for all making Chitra a different place to work. I attach an opportunity, Dr. Unikrishnan Nair, the former director of VSSC. He has also been, the last 2 days he was with us for our review meetings, and I think he has been extremely a helpful person for our institute, and for making today's his presence is a special one. Not least, I wanted to thank all the people who has worked for these 2 labs, in the skill lab as well as the space med lab, Professor Manikandan, Professor Jayanand, Professor Sajid, Professor Dr. Anil Kumar, Dr. Anidan, Dr. Shenai, and Dr. Harikrishnan, and also Sabu and Binu and Deepa, are all the people, tirelessly working to make this happen today and making all the arrangements. And once again, we thank you all for coming here for such a gathering. And thank you once again. We look forward for more research efforts, and anybody can, because of there are a lot of funds are available. So any idea can be really go to these type of very exotic applications. So I really appreciate, because they are very kind here, and we will have more meetings and other thing. So, but any idea we can discuss, and we will be putting the necessary informations with respect to the combined projects in the site, as well as in the information will be given to you, so that we can all work together for this very, very important mission of human space station. Thank you very much.
We have come to the end of the program. May I request everyone to kindly rise for the national anthem.
जनगण अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष मागे, गाहे तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे, जय 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 हे.
This concludes this program. Thank you all for your presence and participation. You're all cordially invited for the refreshments arranged outside the hall. We wish you all a pleasant evening. Thank you.